Alright, this is Math 110, Chapter 10, Section 1. Now we're going to learn about non-right triangles, or otherwise known as oblique triangles. So oblique triangles does not contain a right angle. Okay, so there's only two types, acute or obtuse. So you either have three acute angles, or you have two acute angles and one obtuse angle. Obviously, you can't have more than one obtuse angle because it would be more than 90 degrees total. Right? So there's only two types of oblique triangles, basically. It's acute or obtuse, that's it. Okay, so you want to solve the oblique triangles, which means figure out the lengths of all the sides and the measures of all the angles. So basically, it comes down to you need three pieces of information between angles and sides. You need at least three to figure out all six pieces, because there's three sides and three angles to a triangle. So basically, this is the way it works. If you have three angles, it doesn't work, right? Because it's unsolvable. There are infinite number of triangles that'll make those three angles, basically. If you have two angles on a side, you can use law of sines. If you have two sides, at least two sides, you can use law of cosines. Okay. The other case is the ass case, or ass backwards, which you can use law of sines or cosines to solve those type of triangles. My recommendation is you just always use law of sines for the ass case. So basically the way to remember it is if your car breaks down, you call AAA and then they tow your ass backwards. Those are the cases you have to worry about, because this one never works. This one sometimes works. These ones always work, and those are all the different permutations of angles and sides if you have three of them, basically. So angle, side, and side, angle, the same thing. You're just going different directions, clockwise or counterclockwise on the same triangle. Same thing here. Ass and ass backwards are just going clockwise and counterclockwise around the triangle. Okay, so law of sines is basically a ratio of the sine of the angle to the side length. Okay, so that comparison works to any two of this, or all three of them, basically. And you can put the angle on the top with the sine and the side on the bottom. It doesn't matter. So this way is correct, or this way. It doesn't matter which way you do it, because it's a proportion. Okay, so why does it work? Well, take any triangle that's not a right triangle. Okay, so this triangle over here is not a right triangle. You can draw what's called an altitude and make a right angle. So now you have two right triangles. You can do this for any non-right triangle. You can make two right triangles. You're like, wow, just use SOHCAHTOA. Well, SOHCAHTOA only works in right triangles, so that's why we're going to make two right triangles out of the non-right triangle. So if I take the sine of angle A and the sine of angle B, the sine of angle A is opposite over hypotenuse, so H over B, because if I look at A, that's the opposite, that's the hypotenuse of triangle 1. Okay. If I look at sine of angle B, that's H over A. Because if I look at B, that's opposite, that is the hypotenuse of triangle 2, right? Okay, so if I multiply both sides by B, I'm going to get H equals B times the sine of A, right? And if I multiply this side and this side by A, the A will go away, and I'll get A times the sine of B, right? So basically what I did was I multiplied by A on that side, and I multiplied by A on that side, right? Which will cancel the A over here, and so it just leaves me with an H only. But I'm not going to type that. Okay, so now they're both equal to H. So basically this is equal to this. Right? Format color blue. Format color blue. Okay. Now I'm going to divide both sides by A and B. Okay, that'll leave me with two ratios. Okay, so this side is going to be divided by A and B, and this side will be divided by A and B, right? So what that is going to do is it's going to cancel the B on the left side, and it's going to cancel the A on the right side. So basically we just proved why the law of sines works, basically, right? Because I could have picked A, B, or C as far as that, and I got this version. If I flipped it, I'd get to the other version, basically. Either way, because it's a ratio of angles to sides, essentially. Okay, so let's try a problem. Well, first off, the obtuse proof is very similar. I'm not going to do it. It works basically the same. Okay, so by definition, solving an oblique triangle is when you determine the sides of the lengths of all the sides and the measures of all the angles. Okay, so let's try this question here. Okay, so given an angle 46 degrees A, 63 degrees for C, and 56 inches for C. Okay, so we're going to label the things that we don't have, which is side A and side B. And we'll have to figure out the third angle B, or maybe not, I don't know. Okay, so if I draw that triangle, we'll get this here. And you can mix it up, you can turn this around basically. Doesn't have to be any particular orientation. Okay. Okay, so the question is, what case do I have here? Well, this is a side angle, right? Or angle, side, right? That's what we have essentially. And you can't skip I can't skip an angle to go to a different angle, right? So I can't skip this one to go to this one. You can't skip a side to go to a different side, so you can't go that way, right? So essentially, you can't skip a side for another side, and I can't skip an angle for another angle, basically. So you have to go this way, essentially, or this way. Okay? All right. So I am skipping a side here, but it's not to get another side. It's to get an angle, right? I can't skip an angle to get another angle is essentially what I'm saying. Okay, so what this is essentially a angle, side, or a side, angle. That's the case I'm doing. Okay, so we'll make a ratio now. Equals a ratio. So the only ratio I know is angle C to side C. So the sine of 63 degrees to 56 inches is the only known ratio. So we'll compare that to what we have. So we have 46 degrees for A. So you have the sine of 46 degrees to side A. So A is the missing piece. Okay, so what we need to do is cross multiply. So if I cross multiply, it's A times sine of 63. So A times the sine of 63 equals 56, right? 56 cross multiply times the sine of 46. Okay. Then we're going to divide both sides by sine 63. So we'll take this here, copy, paste, and we'll divide this side by the sine of 63. And we'll divide this side by sine of 63. Okay, so that means A is equal to this. So A is approximately some value. Okay, all right, so let's take a second here, load the calculator. Doesn't matter what calculator you use as long as it's in degree mode, not radians. Okay, so this is the calculator I have. That's my calculator app, so I need to make sure it's in degrees, essentially. Okay, so ratio 56 times the sine of 71, right? So 71 degrees, so that means degrees is what I'm plugging in. And sine of 63, I believe. And approximate. So 59 Did I get that right? Let me just double check here. 56, 46, 63. 56. No, I did the wrong one. I'm sorry. Let me just double copy that, paste that, and we're going to put a 46 here. 63. Okay. I was off by 1. Alright, so we'll say 45.21. So 45.21, and these are in inches, right? Format, color, orange. Okay, so we also need B, but we have no information for B, which is fine. I can figure out the angle, right? So it's because essentially, oops, we have 46 and we have 63 degrees, right? Oops, that's not degrees. Let's try that again. The whole triangle is 180, right? So 180 minus those will give me so let's see, that's 109. So if I subtract that, I will get 71, which is angle B, which is the other piece we need. So it's format, color, orange. Okay, now that I have angle B, I can do the final ratio. So I can use the ratio that I had, I know for sure. Okay, I don't want to use the estimate because this one right here, dot, 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 is an estimate. I don't want to use that. I want to use the one I know for sure is an exact. Okay, so now I can do this ratio, which would be the sine of 71. Because I know that for sure for B, right? I just don't know the length of B, essentially, right? So if I cross multiply, I get B times the sine of 63. And 56 times the sine of 71. Okay, and I'll take that and divide both sides by the sine of 63. So B is equal to this value here. Alright, so B is approximately, I believe we already did this one, 56, 71, 63. 56, 71, 63, we already did that one, so it's 59.426, I guess, 59.426, 59.426, dot, 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 in inches. Format, color, orange. Okay, so there's our all the measures and all the angles. So we have 3 side measures now because we found the 2 missing ones and we found the missing angles. So we have 3 side angles. Okay, that is the end of part 1.